Welcome to this lesson on series circuits. A series circuit is a fundamental concept in electricity where current flows through a single continuous path. Understanding series circuits is essential for grasping how electrical components interact in real-world applications. A series circuit is a circuit where all components are connected end-to-end, forming a single continuous path for electric current to flow. Think of it like a train moving along a single track with no alternative routes. The current must pass through each component one after another in sequence. In the circuit shown, current flows from the battery through resistor 1, then through resistor 2, and returns back to the battery. The defining feature of a series circuit is that current has only one route through the entire circuit. This is fundamentally different from a parallel circuit. In a series circuit, there are no branches or alternative paths. The current must follow the same single loop. In contrast, a parallel circuit offers multiple paths for current to flow, allowing it to split and travel through different branches simultaneously. In a series circuit, current is identical at all points. This is a crucial principle to understand. Whether you measure the current before the first resistor, between components, or after the last component, the value remains the same. This happens because there is no accumulation or loss of charge anywhere in the circuit. The formula shows that current at position 1 equals current at position 2 equals current at position 3 equals total current. This constant current is one of the most important characteristics of series circuits. While current remains constant in a series circuit, voltage behaves differently. The total voltage supplied by the battery divides across all components in the circuit. Each component gets a portion of the total voltage. The formula is total voltage equals voltage 1 plus voltage 2 plus voltage 3 and so on. For example, if a battery supplies 12 volts and there are 3 equal resistors, each resistor will have a voltage drop of 4 volts across it. The sum of all individual voltage drops always equals the total voltage supplied. Resistances add up in series circuits. To find the total resistance, simply add all individual resistances together. The formula is total resistance equals resistance 1 plus resistance 2 plus resistance 3 and so on. For example, if you have 3 resistors of 10 ohms, 20 ohms, and 30 ohms connected in series, the total resistance is 60 ohms. This is straightforward addition. The more resistors you add in series, the higher the total resistance becomes. Series circuits are found in many everyday devices. String lights, like holiday decorations, are a common example. All the bulbs are connected in series along a single wire. This is why when one bulb burns out, the entire string often stops working. Another example is a simple flashlight. The battery, switch, and bulb form a series circuit. When you close the switch, current flows from the battery through the switch to the bulb and back, completing the circuit and lighting the bulb. Let's summarize the key characteristics of series circuits. First, current is the same at all points in the circuit. Second, voltage divides across the components, with each component receiving a portion of the total voltage. Third, total resistance equals the sum of all individual resistances. And finally, a critical limitation: one break in the circuit stops the entire current flow. If any component fails or is disconnected, the whole circuit stops working because there is only one path for current.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.